Madeline and Kristen, after having completed their engineering degrees and their Master of Business Administration degrees, have created a company that produces electric cars. They produce two types of car models. The Model M is a carbon fiber sports utility vehicle, SUV. The Model K is an all-aluminum sports car. They are able to produce at least 8 sports cars per month and at least 6 SUVs per month. The total number of cars is at most 24. The number of sports cars is at most 2/3 of the total number of cars produced. The women make a profit of $8,200 on each sports car and a profit of $6,800 on each SUV that they produce during a month. The two entrepreneur engineers wish to produce an amount of cars that will maximize their profits. The two women each receive 1/3 of the profits, which they will both place in bank accounts. The other 1/3 is donated to an organization that promotes girls' education. Kristen invests her share of the profits at an annual interest rate of 8% for 5 years, compounded monthly. We come across the Model M car first, and then the Model K. It would be easiest to make Model M X. But X equal the Model M SUV, and Y will be the Model K sports car. They are able to produce at least 8 sports cars per month. Y is at least 8, so greater than or equal to 8. And at least 6 SUVs per month. X is going to be greater than or equal to 6. The total number of cars. The total number of cars is X plus Y. X plus Y is at most 24. It can be smaller than 24, so less than or equal to 24. It just can't be greater than 24. So X plus Y less than or equal to 24. The number of sports cars is at most 2/3 of the total number of cars produced. Sports cars is Y. Is at most is going to be less than or equal to 2/3 of the total. The total is X plus Y. You have 2/3 times X plus Y. The women make a profit of $8,200 on each sports car and a profit of $6,800 on each SUV that they produce during a month. The two entrepreneur engineers wish to produce an amount of cars that will maximize their profit. If we're looking at the profit formula, it would be 8,200 times SUVs are X, right? So 8,200Y plus 6,800X, or 6,800X plus 8,200Y is your profit is equal to P. Let's go and graph these things. We're going to graph, and graphs should have titles, and you need to label your axes. This is the number of Model K cars. X-axis is the number of Model M cars. I'm just going to rewrite my inequalities on this page. I need to get this in terms of Y. Everything needs to be in terms of Y except for this one, which is obviously in terms of X, so it's vertical. Here I want to get rid of the X, so I subtract X from both sides. We have Y is less than or equal to negative X plus 24. Then I have this 2/3. The easiest thing to do is just get rid of the 3. Like whenever you have a fraction, you want to kill the fractions, you multiply everything by the common denominator. In this case, we only have one denominator, it's 3. So if I multiply each term by 3, and remember, this is one term. We don't see inside the brackets. So I'm multiplying the Y by 3, and I'm multiplying the 2/3 by 3, which just gives me 2. Or you can think of this as cross multiplication. The 3 comes up and multiplies the Y. We get 3Y is less than or equal to 2 times X plus Y. The 2 comes in, multiplies the X, multiplies the Y. We get 3Y is less than or equal to 2X plus 2Y. I want to get all the Y's on one side, so I'm going to subtract 2Y from both sides, and that gives me Y is less than 2X. Here are all my inequalities, and I need to graph them. If I start with this one, X plus Y is less than or equal to 24. There's my B value, is my 24. And my slope is going to be -1. We can go over 1, down 1. So you can use the big squares too, right? Like you can go over one big square and down one big square, and it'll bring you to here. So that's a good point. But over 1, down 1, over 1, down 1, over 1, down 1. If you're on paper, you want to make sure that you are not, picking these 2 points. It's too close on paper. Your ruler, the angle between these 2 points is going to be off by a lot. You want to make sure on paper that you're going to go as wide as possible. One way is you can go over 1, down 1, over 1, down 1, over 1, down 1. You just keep doing that until you get really, really far away. Okay? Or I can go over one big one and then down over one big, down one big, over one big, down one big, over one big, down one big. These are 2 good points. Yeah, I kept doing it like over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, till I got them as far apart as possible. And then on paper, you can just put your ruler down and draw your line. But they're far apart, it's hard to make a mistake. This is less than or equal to, so I'm shading below. So I just put a little arrow to remind myself later on that I'm shading below. Y is less than or equal to 2X. The b value is 0, so it's going to go through the origin. The slope is 2. That's 2 over 1, so I'm going to move over 1, up 2. The same thing, right? So you keep doing that over and over again. Over 1, up 2. 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 I went further. Over 1, up 2. Over 1, up 2. Over 1, up 2. So I went as far as possible to here. And then you draw your line. This is less than or equal to, so I'm shading below. The next one, y is greater than or equal to 8. Here's my 8. It's a horizontal line. And greater than or equal to, we are shading above. Then we have x is greater than or equal to 6. So here's my 6. I'm going to have a vertical line going through this point. X is greater than, we're shading this way. My polygonic constraints is going to be here. Now I want to look at each vertex. You can look at each vertex, put it into a spreadsheet or whatever, but each vertex you're going to be using your profit formula. If I was looking at this vertex, you don't know which one is going to be your maximum. You have to test each vertex of your polygonic constraints. Every single point inside this polygonic constraints is a solution. This is a solution. It's not your maximum though. This is a solution. It's not your maximum. You can't have a fraction of a car. So there are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's a whole bunch. There's like, maybe 60 different solutions that are possible here. But there's only going to be one maximum. We don't have any dotted lines in this question. But if it's on a dotted line, it cannot be the solution. The solution is never on a dotted line. We have this. I'm going to do a scanning line. You don't have to do a scanning line. I don't know whether it's going to save you time or not. I think it's easier just to plug these points into this equation and find out which is your maximum than to do the scanning line. To do the scanning line, I've just switched everything. I put the 6800x with the p. So I subtracted 6,800x from both sides, and then just wrote it. I put the y on that side and put everything else on this side. Then to get the y alone, I divide by 8,200. Y is equal to negative 6,800 divided by 8,200. You can just chop off the 0, 68 over 82. Then divide both the 68 and the 82 by 2, and you get 34 over 41, which is fine. Notice I can't move over 41. I divided it by 2. I'm going to move over 17 and 20.5. Notice our p disappeared, and I just write b, because we don't care about the b. It's a scanning line. We're scanning it up and down, so we don't really, it doesn't matter what our b value is. If I start off with a b value, like up here as 25, I'm going to move over 20.5. So that's 5, 10, 15, 20.5 is like here. And then I'm moving down 17, 5, 10, 15, 16, 17. So here's my second point right there. Here's my original line, and I scan it down to here. And we can see that this is going to be either a maximum or a minimum, but because it's plus, it's going to be a maximum. Then if we scan it through here, this will be our minimum. But we can ignore these two lines, these 2 points. So my point here is 816, and then I have this point, which I called B. You can call them whatever you like. This is at 16.8. This point is at 6.8, and this point is at 6.12. I'm going to run each of these coordinates through this formula to figure out what the profit is in each case. So I'm going to multiply the 8 by 6,800 and the 16 times 8,200, and I put it in a spreadsheet, and it will give us, for our maximum, is $185,600 profit. For B, this point, we only get $174,000. For C, which is going to be our minimum for sure, is going to be $106,400. D, which is not our minimum, is $139,200. We know our profit, our maximum profit is going to be point A, which is 8 and 16. There's our profit. The two women each receive 1/3 of the profits. The profit is $185,600. which they will both place in bank accounts. The other 1/3 is donated. Kristen invests her share of the profits at an annual interest rate of 8% for 5 years, compounded monthly. Monthly means 12 times per year. The M is going to be 12. To figure out the C sub 0, they're all each going to get 1/3 of the profit. So I'm going to divide this number by 3. They're each getting $61,866.66.6 repeating cents. Our formula for compounded interest is C sub n, or C sub t. Like I usually use n. I don't know why I'm suddenly using t's. You have C sub n is equal to C sub 0 times 1 plus I to the power of n, where I is j. That's the nominal rate or the yearly interest rate, divided by m, the number of compounds per year. It's 8% divided by 12, which is going to give us 0.06 repeating. Don't just chop this off to 0.06. it's 0.0666666666. N is m times t, where m is 12 in both cases, right? So it's going to be 12 times the number of years. And she's investing it for 5 years. It's going to be 12 times 5, which is 60. Plug everything we know into the formula. So $61,866, 66.666666, repeating, cents, times 1.006, repeating again, to the power of 60. Handy dandy calculator. 61,866 point, and just make a whole bunch of sixes. Times, like even if you're off, even if you round it to the nearest cent, it's going to be off. Times 1.00, same thing, a whole bunch of sixes, to the power of 60. That will give us $92,171.79, really. You round to the nearest cent, which you should. $92,000. And then it's an ES, so they just keep hammering you with questions. For how long would Madeline have to invest her share at a simple annual interest rate of 8% to gain the same acquired value as Kristen? Simple annual interest, which is this formula. C sub n is equal to C sub 0 times 1 plus I times t. How long would it take her to get the same value, to get $92,171.79? We're going to plug that back in. You need the 61,866.66, repeating, times 1 plus 0.08 times t. This 0.08 is multiplying the t. These are not like terms, they can't be added. You would have to do the multiplication before you can do the addition, order of operations. I want to get rid of the 61,866.66, repeating. I divide both sides by that, take this number, copy this. And then I'm going to divide that by the 61,000, so 61,866.6 equals. That gives me 1.4898. Keep that number in your calculator. You can write it to like 2 or 3 decimal places here, but keep the number in your calculator is equal to 1 plus 0.08t. I want to get rid of the 1, so I subtract it from both sides. That's going to give me 0.489 is equal to 0.08t. To get the t alone, divide by 0.08, subtract the 1, divide by 0.08. It is equal to 6.12. It's going to take 6 years. Madeline would have to invest her money for 6.123 years to make the amount that Kristen made in 5 years. You want to convert this into months, like the 0.123. So I take the decimal point, and I'm going to multiply that by the number of months in a year, which is 12. So times 12, that gives me 1 month. Or let's say there are 30 days in a month, approximately. I could multiply the 0.47 times the days if I wanted to be fancy about it. So subtract the 1 off of that. And then times 30 is going to be 14 days. It would be 6 years, 1 month, 14 days, stop there. Really, 6.123 years is fine. And that's your practice ES.